So there comes your 2D over T. So before that, we have to talk about the concept of reflection of sound. So we have a sound source, and then we place it in front of a wall. So it must be a hard surface, a flat surface, because hard surface and hard surfaces don't absorb sound as much. So then you put a cardboard tube down here, then after that the sound will go to the wall, and then the user, you placed it at the same angle, I equals to R, then the user here, observer here, will hear the sound of the clock ticking. Okay, so there's this here to prevent the sound from traveling directly this way. So that's what's happening here in the experiment. Eventually, the user will hear the sound, so which then tells you that sound is reflected, like how light is being reflected. So light in light, right? The angle of the reflection of light, angle of incidence is also angle of reflection. So sound waves and light waves, they behave the same way. So this reflection will cause something called an echo, or another thing called a reverberation. This one is for interest sake only. So you have the definition of echo here. So you get echo when sound is reflected off hard surfaces. So you clap, clap, clap here, the sound will go there to the wall, and then after that you come back, the sound will come back to you, and you hear the clap, clap, clap. So then, right, one thing to take note is the echo will be softer than the original sound because energy is lost. When the sound travel to the wall and come back, energy will lose some way in some manner. So some way or the other, the energy is gone. So you will hear the echo but it's softer. So this is reverberation.
How is that echo? Because won't the sound just go through the wall?
The wall won't absorb sound. So most of it will come back reflected, and a tiny bit will go through the wall.
And how does sound go through solid if the wall doesn't absorb sound?
So this is your wall, okay? The cross section of the wall. The cross section of the wall is made out of particles because bricks and walls, they have atoms inside. Agree? So then you have the so and so two people gossiping with each other. Okay, then they talk, they talk like that, right? So this talk will provide vibration, then the sound will like that, right? So then, and possible something like this will happen. So that is the echo. Okay. So what happened is, right, part of the energy will go into the wall, cause this to vibrate. Then they like that, they move closer to each other or they move further away from each other. That we don't know. But eventually this sound, if you put your ear down here, you will catch the vibration and then you hear it. That's one. Then this part, right, the reflection of sound, what happens is the echo happens. But do you realize that when you speak at home in the room, you don't hear the echo? You don't, right? You don't hear the echo, right? Okay, why do you not hear echoes in your room when you speak?
Because the surface is not clear.
Sorry, cannot hear.
Because the surface of the wall is not clear.
Not clear?
Because it's not clear.
You want to type out that word? I couldn't hear that word. So, okay, let me explain why in the room you speak and then you don't hear yourself. Okay, so I don't know if you have this experience, but when you move to a new place, the house is empty, right? So if the house is empty and then you and your parents start speaking in the room, right? Then you will hear the echo of yourself in the room if the house is empty. Because what happens is when the room is empty, you speak, the sound goes out to the wall, and then because there are only 4 walls and one ceiling and 1 floor, the number of reflecting surfaces is quite low. So you will create echo and the sound will come back to you. The sound wave goes into your ears and you hear it, so you hear the echo. Then after
you don't hear the echo because the echo travels too fast.
No.
Until it is.
It's not. Then after that, after you come into the house, after you furnish your house, then you will put in your chair cupboards and then maybe table and all that. So when that happens, you introduce more reflecting surfaces.
Because there is too many reflecting surfaces.
Yes. So when there are many reflecting surfaces, when you speak, all of them will start reflecting your whatever you speak. So
When
when
there's too many surfaces and there's too many echoes.
the sound waves that is reflected will interfere with each other and they cancel out each other. Then you
So
will
that's
not
why
hear your
you
echo.
cannot hear the echo.
Yes. So many reflecting surfaces means many echoes come out. Many echoes come out because they're all waves. Later on, you will learn that waves can cancel each other out. So when they cancel each other out, you cannot hear anything. You cannot hear the echo. Then another thing is you have those soft surfaces. Soft surfaces. Soft surfaces are like your, blankets, curtains, sofa, couch, all this, the soft ones, right? What they do is they will absorb some sound. So then, of course, when you speak in a room with your sofa, your couch, your curtains, and then your cupboards and all that, they will just either get absorbed or they get reflected. And when they are reflected, they cancel each other out. Then you don't hear that.
Is it like the wave cancel each other out? Is it like when you make two water ripples in the pool, then they get into contact with each other, then they just disappear?
Yeah, in some sense it is. Let me change color and draw something. Okay, so it's like this. You have your wave. Wave can come this way. Then you can have another wave. It travels and then it comes this way. Because this one wave could have traveled earlier, one wave came out later. So then you'll end up like that. When it's like this in this order, right? The two waves will cancel each other out. Then the wave will become like that. So it's zero amplitude, then you cannot hear anything. So this is when waves cancel each other out. But it's all for information sake only. You are not required to know, this is not in your syllabus. But of course, if you're interested, you can go and read out about it. There are terms called standing waves also, which is not tested. You want, you can just go and Google and have a bit of fun. Okay, Ken?
Yeah.
So the second thing is the reverberation. So reverberation is like this. You have multiple reflections, and then the reflection come from multiple surfaces. So the sound will get like extended because the wave, right, they merge, the echoes will merge together. So like the direct sound is like this, but this guy, his violin, the sound will go this way, go this way, go to this wall, and then go to this wall, go to this wall, and go to this wall. Then after that, right, the sound gets reflected by the hard surface here, and then it comes back at the same time to this person. So in the end, right, then all the echoes get merged. Then you get a sound that is extended. So you can go to those concert halls. When you watch concerts, you may observe this effect. Then
Reverb is many echoes merged together.
yeah, then you will get a sound that is extended. Sound like it sounded to you like it's extended. If you want to know more about it, you can go to this side and then you look at, this is not tested. This is, I put on this slide here, I say it's extra info only. Okay, the first very common thing is they use it to detect the depth of the sea. So that this one, right, appears in a lot of calculation questions. So you use it to find the depth of the sea, or you use it to detect for any obstacle or fishes under the sea. So if is in this case, right, is used to detect fishes. So the ship will send a pulse of sound downwards. So it goes down this way. So once it hits the fish, right, the sound will be reflected and it returns as this wave here, and then the boat will detect the echo. Then from there, they can calculate and find where the fishes are. So depth of sea is also the same. So we just remove the fish and then put it as the seabed. The same things apply. Then detection of mines, you just need to know there's such a thing. And then the detection of obstacles by the bats, you just need to know they use echo. These two are not commonly seen in calculation questions, but they may ask you for explanation, like a 1 mark explanation, etc. Those, it's still possible. For bats, detection of mines, I don't really see that kind of question. So this one is an experiment to determine the distance of a wall from maybe a person using echoes. Then this is the procedure. I have it like that so that if if you have a question that ever asks you for, please describe how you will measure the speed of sound using an indirect method. If they ever ask this kind of question, you can reproduce these steps as your answer. Okay, so when they say indirect method, they only refer to echo, because previously we have this one. We have this experiment to find the distance or find the speed of sound using this method. This one is the direct method. They ask for direct method is this. If they ask for indirect method, is always the echo. So what happened is you have a person standing here. You can use this to create sound, two pieces of wooden block to create sound. Or you may have someone say screaming away at this position to create a sound. But using the wooden block, it's more consistent than screaming to the wall. So they say you will measure the distance between the person and then the large wall here. So you're going to measure. So then they say there should not be any reflecting surface nearby. So an advantage of this is the distance will not be as the distance is not as long as the one you use in the direct method. So this one you can use a few hundred meters is fine, as long as there's no other reflecting surface, no other walls nearby. So then the person will make a clapping sound with the wall, the wood. Then after that, the sound will go to the wall and it comes back. When the sound comes back, the person hears it, right? They will just make the same sound again. So you will repeat this thing, creating the sound for about 50 times. Then when that happens, right, then because they measure the time when the whole procedure starts. So that means at 50 claps, right, there will be a certain amount of time. So you repeat the step 3, then after that find another few time taken for 50 claps, then you find the average. So once you find the average, right, then you can find the time interval between the claps. Then because you have the time interval for the claps, then you have the distance, then you can find the speed of the sound. You just need to know got such a thing, such a method will do. If they ask for description, show them the description here. Then if they ask for calculation, you use the data provided by the question and use this formula here to do the calculation. Okay, all right. First question is definition. So what is meant by echoes? Okay, next one. Hey, okay, so you have a long story down here. Then it's easier if you draw it. So a student is standing between two high walls, like a distance 540 and 180 from each wall. Then he gives a loud clap and then he hears two echoes. So then find the time interval between two echoes. So this way, we call this T1. This way, we call this T2. So we define it this way, then you can continue. Speed equals to 2D over T. Look carefully. Okay, time to critique. Gave you these two numbers here. I named the two time interval for you. So then there's T1 and then there's T2. At the very start of your question, you will write the speed of sound is this. Then after that, you will give time equals to distance, to distance divided by speed. So you present this, you present this. Then after that, right, then you do your T1, which is 180 times 2 divided by 300, like that already. Then you write the answer. Then from second part onwards, right, because you have written that formula there already, right, you don't exactly need to write this anymore. Then you just go ahead and continue and you get this. Then you can put time interval equals to this, like that. Easier for markers to read, easier for you to check your answer. Okay? Then the fifth question. You see that this drawing is somewhat similar from whichever drawing you have just now.
What is 1500 meter per second minus 1?
This is 1500 meter per second.
Then what's the minus 1?
Okay, so if you have indices, you have this. So indices, you have this, there's this rule where you have a to the power of negative n equals to 1 over a to the power n. Like that, s to the power minus 1 is 1 over s. So if you have 1500 meter s minus 1, right, is the same as 1500 meter 1 over s. So meter per second and meter s minus 1, right, is the same thing. It's just that certain books, they write it in this manner and other books prefer to use the other way. Okay, so you label this as D. Done?
Yeah.
Next. So D is 300 meters now. Then the speed is 1500.
What is kilohertz? kilohertz is to the power of what?
10 to the power 3. Units, meters per second. So wavelength is a length. So the units of length should be in meters, centimeters, millimeter. You will see that the same question, the same setup, you can have different permutation of the question. Just now, they gave you the distance and they gave you the speed. So they want you to find the time interval. This one, they give you the time interval, they give you the distance, then they want you to find the speed of sound. So they say a person stands between two walls like X. When he claps one, the sound goes this way and the sound goes this way. So I call this T1 and I call this T2. The time lag means the difference between T1 and T2 is 4 seconds. It's a 3-step or at least a 2-step question. Can you please explain your answer?
Because they asked for the speed of sound. So and then they gave the difference between the two times.
So
then I
then
found I found the difference between the distance. Then I times 2, then I divide by 4.
Okay. But conceptually it will mean this.
Yeah.
So this is what you found. It is actually a factorized form of this, but you must know that it is actually the time difference equals to 4. So 1250 minus 600 times 2 divided by 4. Then the same thing again, they rephrase the question, but you may not be able to do this with the same method you have for the last question, for the previous question. You want to reconsider your answer? Draw out the situation, okay? So you have this way. Then where is 330 and where is the other 485 or 495? So you must always draw. Okay, it doesn't always mean that one minus of the other one. So you have to look at where the distance is before you decide to add or subtract. Okay, so if you see sound questions and it's a calculation question, they will all kind of revolve around this kind of question. Calculation wise, it will be like that. Don't think it will be too different. Okay, so I think you're totally fine with this already. Then the same story again, then they rephrase the question and then they added some other factors. So can you tell me what's the difference between this question and the other few questions that we did? And this is an example of where distance is matters.
It's not an echo question.
Sorry?
It's not an echo question.
It is an echo question. If you read the question carefully just now, the other question, what you did was you have this, then you have this here, and it comes back, right? Then you have T1 and T2, or distance 1 and distance 2. So then they ask for the distance traveled, then you add D1 plus D2, right? So now in this case, what is the difference? You have the boat here, okay? Then it's sailing in the ocean. Then we have the seabed down here. They say it sends a sound wave down and the reflected sounds come back after 1.2 like that. So then the seabed moves and then now it passes over a hump. Then send signal down, signal return, right? Then now the distance is D1. Then the time taken will be 0.76. The story is like this. Okay. So then now they say calculate the height of the hump. So is this scenario the same as this where I add up the two distance that I find, or is it otherwise?
The first distance minus the second distance.
So that is the distance. That is the difference between these two questions where I say the drawing or the setup of the question matters, where the person stands and all that matters. It doesn't mean that you always add or you always subtract. So you have to look at you have to sketch out the situation and decide whether to add or subtract. Okay. Point made, so you can do the question already. Okay, I will leave the below space for you. You probably still need the diagram. Done? Yours is 519 or 319. Cannot exactly see.
319.
So be careful of presentation.